Okay, today we are going to start 1D verbal expressions. So to translate verbal phrases into expressions, look for words that indicate mathematical operations. So we have here a bunch of different concepts that are going to represent one of the operations. So addition. If we're adding, you might be looking for the word sum, plus, total, more than, increased by. So if you're looking at your packet, you can see an example of a verbal phrase, the sum of 2 and the number x. That would mean addition. So the expression of that verbal phrase, would be 2 plus x or x plus 2. We could also flip it around, x plus 2 as well. Another example would be a number n plus 7. That was pretty literal, just n plus 7. So you can see that in the word phrase form and the expression form. Subtraction. You might be looking for the word difference or less than, minus, decreased by. So an example of a verbal phrase could be the difference of a number n and 6. Now this order does matter. When you have a subtraction problem, you cannot switch the order and get the same answer. So it's important for you to realize the first number they say in the word phrase is the first number that has to be written in the expression. That's why it's n minus 6, because they said the difference of n and 6. Same thing for the next one, a number y minus 5. Y is first, and then the minus sign, and then 5. In that only that order will work for subtraction. Addition can be switched around because of the commutative property of addition, but it does not work for subtraction. It does work for multiplication though, but here are some multiplication operations. So times, you might hear, product multiplied by. The word of means multiply. So here's some examples of verbal phrases and expressions that match those. 12 times a number y. So the expression would be 12y. 1/3 of a number x. That's important because it says 1/3 of a number, and that means multiply. So 1/3 times x is the expression. And the last one, division. You might be hearing the word quotient or divided by, divided into. An example of a word phrase, an expression would be the quotient of a number k and 2 would be k divided by 2. So it says here underneath of the key concept graphic organizer here that order is important when writing subtraction and division expressions. For instance, the difference of a number n and 6 is written n minus 6, not 6 minus n. And the quotient of a number k and 2 is written k divided by 2, not 2 divided by k. So here are two examples. They want us to write verbal expressions for the algebraic expressions. So this says 6n minus 4. So in order to write a verbal expression for this, we have to realize that there's a 6 times n and then minus 4. And we can just write that 6 times the number n minus 4. But I kind of like using the fancier words. So I would say the difference, since that means subtraction, so the difference of, and then I would write the first term first. Well, the first term is 6 times n, and the second term is 4. So the difference of 6 times n and 4 would be an example of that. But you might have a different example that represents that same exact expression. All right, the next one, 3 times the quantity of 7 plus y. So there might be a few ways to write this, but I'm going to say this is going to be the product of, since product means multiply, and the two things that are being multiplied are 3, product of 3, and the second part is kind of hard because it is it's a quantity. So that means it's not just one number, it's the quantity of the sum of 7 and y. So I'll say the product of 3 and the sum of 7 and y. Now you might have a different example, and that's kind of why it's cool for this section, because everyone might have a little bit of a different answer. So we can be creative. If we flip over to the next page, we have some more. Let me just erase all of this. Flipping this over to the other side here, I have 22 minus m squared. Well, I'm going to use the fancy word for subtraction, that's difference. So I'm going to say this is the difference of, and you would write the first number first, so 22, and the second number is m squared. All right, and then the fourth one. This one is a little tricky because we have a fraction, and fractions are division problems as well. So we can call this the quotient. Quotient means divide. And then the numerator would be the first thing you write. So it's the quotient of, and then the numerator is 10 plus x. You could write it like that. Or you could say the quotient of the sum of 10 and x and 2. But I'm just going to say the quotient of 10 plus x, and the second number is 2. All right, in the next section, we have here word phrases or verbal phrases, and we are writing the algebraic expression for those. So for the first one, it says the product of 6 and a number y. So creating an algebraic expression for this, we would just read the word phrase and come up with what expression matches this. So the product of 6 and number y would just look like this, 6y. So you can just put them next to each other, and I will know that that means multiplication. You could also use like a floating multiplication sign. You could use parentheses if you would like to show multiplication. The only thing that I don't want you to show is like 6 times y. And you might be wondering why. Like that looks like 6 times y to me, but that looks to me like 6 times x times y. So we're not going to use this because this could be accidentally mistaken for something else, because I know back in the day you use x for multiplication, but now we use x as a variable. So I want you guys to try 2, 3, and 4. And then if you flip over to the next page here, if I scroll down, you can still see all of my stuff here. There are some examples here that you're going to be writing the algebraic expressions for certain word problems. Let me erase this so we can see. Please just erase. Okay, not going to work that way. All right, so on the next page, it says write an algebraic expression for the situation. So the number of tokens needed for V video games if each game takes 4 tokens. So we're creating algebraic expressions for now word problems as well. So the number of tokens needed for V video games if each game takes 4 tokens. So if you want to play one video game, you're going to need 4 tokens. If you want to play 2 video games, you're going to need 8 tokens. So basically what's happening here is you need to take 4 and multiply it by each video game you are going to be playing. So this algebraic expression would be 4V, or V times 4. So what I'm going to have you guys do now that I tried one example in each of those problems is complete 2, 3, and 4 from both of these pages. So you're going to complete the rest of these on this page and then scroll back up and you're going to complete these up here. And then we'll go over these as a group.